Hello everyone, Tech Vibes here. Today we will be designing a Gib and Cotter joint. So let's get started. So start with fork, click start sketch. I'm going to click on side view, construct three rectangles. Okay, it's in inches. Set the default to mm. 25 and this is supposed to be 35.5 plus 19 plus 16. Construct another rectangle. This is 12.5 and this is 85.5. Same posture over here. 12.5, 85.5. Okay, I'm going to extrude this three rectangular profiles. Extend the side up to 25 and click OK. So we have got the rough design done. Now we'll have to add fillets to these two edges and then we'll have to add a rectangular hole in between. Okay, let's call it a slot. So let's just add the slot now. Click on project geometry to project all the required lines and get a rectangle, and this is 7.5, this is 35.5. Okay, time to constrain the center point. It's going to be 2.5. And click here. The constraint should be 16 plus 35.5 by 2. Click on OK. And finish sketch. Click extrude. Click on the profile and click on the through all option to cut through the object, through the model, and there we have it, rectangular profile. So we just have to add it, fillets. So by default it's 2 mm, which is fine for this model. Right. So we're done with the fillet part. Now we'll proceed with the rod. Rod is just a plain rod. It's not much into it. It's just a square rod with the slot as we did in the fork design. So you click on the center rectangle, 25, 25, click on finish sketch, click on extrude. So the extrusion length is 19 plus 35.5 plus 16. Okay, not 16 specifically, I'm going to add 50 because there's no defined length here. That's okay. Fine. Then we have to add a slot like we did for the Gib and Cotter joint. Slot dimensions are again 7.5 and 35.5. Time to dimension the center. 19 plus 35.5 by 2. And this is 12.5. Done. So click on finish sketch, click on extrude option, through all, and yeah, we have the square shaft ready. Now return back, turn off the visibility, create a new body. This time start with quarter, start sketch, click on this profile, get a rectangle done, click on the center rectangle. The dimensions are 87.5 in the length direction and 14.5. Then add two more rectangles on the top for the to add the chamfers at the top. 2 and again 14.5. Okay, here we need to first add a tapered edge for the bottom part and then take a square profile like we did here. So since the angle is given, the tapered ratio is given 1:30, the angle has for calculated tan inverse of 1 by 30 is actually 1.9091. So take a line, 90 minus 1.9091. Okay, that's mismatch 0.9091, 180. Make sure. Okay, and yeah, constrain it properly. Fine. So we know this point now. From here, we need to take the rectangle edge. Fine. Now we just have to extrude it. Extrude. Click on this. Click on the top profile and make sure you don't select the triangle profile here. Okay, so it's given 10 mm. Our thickness is actually 7.5 mm. So yes, we have it done. We just have to chamfer it now. It's given 2 cross 45, so accordingly make sure if the I selected this edge by mistake, so let's do it again. Let me shift my view because I can't see the edges. Yeah, that's good. It's given 2 cross 45 and you can see that it's 2 mm and by default it's 45. So apply, and we have the chamfered edges done. Now return back, turn off the visibility, create another sketch. So create another model. Now we'll have to design the chip. So click OK, click anywhere. Click on Start Sketch. Click on the right profile or any profile you want, wherever you want to start. I'm going to start with right profile. Draw a rectangle whose height is 50 and whose width is 18, right? Now consider another rectangle from here to here. So this is 12.5 cross, sorry, not 12.5, it's 9.5 was 8 plus 18. So the same dimensions here. Okay, we have to add the tapered side now. Again, the dimension is 1.9091. Since the angle is starting from there, I'm just going to add 180 here and make sure you have it properly aligned. Done. Now we just have to extrude it. Extrude this, extrude a small triangle, tapered edge, yes, and click OK. Before clicking OK, make sure you have the width proper. Again, 7.5 and OK. Now you can return. Okay, we just have to add fillets to the edges. So let's add fillet to the edges. Okay, default is 2 mm, which is fine. Now turn on the visibility. Okay, the focus constraint like we wanted. We'll constrain the Gib and Cotter later. We'll first constrain these two rods. So click on the constraint. Click on faces facing opposite direction. So click on this. Click on this face. You can see that smoothly sits. Click apply. This is what we wanted. Now click on faces facing the same direction, that constraint, and click 0. Apply. Now last constraint, again it's the opposite faces. This constraint, this, click apply. Now if you see from the top view, you should be perfect. So exactly what we wanted. 3 mm clearance. That will be locking the quarter. So now we have to constrain the quarter also. And one more constraint and we are done. Ready? Apply. Yes. Now last we'll have to constrain this quarter also. So constrain with respect to faces. Finally, we have to constrain them to the correct height. So by measuring it by hand, I got to know that this height is actually 11.25. Apply, and that's it. You have successfully made a Gib and Cotter joint. So if you look from the top, you should be able to see the 3 mm clearance we gave. Okay. So let's change the appearance. Oh yeah, I have to select it first. Change the appearance to generic. And yes, here we go. So if you like this video, do subscribe to my channel, and if you have any questions, do ask in the comment section. And thank you, and see you in the next video.